Good morning, chat. My name is Penbu, and the programming, puzzle gaming, and music making VTuber on Linux. And today we are finally programming. Uh, I call myself a programming VTuber, and I don't do any programming. Oh well. Glenn, welcome in. Today we are continuing the basic Pascal tutorial on the Free Pascal wiki. Last time we touched this was 2 months ago. I didn't expect to take 2 months between sessions, but stuff happened and here we are. Despite it actually being evening, yeah, that's nature of universal greeting time. You say good morning, and it doesn't matter what time it is, because people all over the world are in different time zones, and some of them it might be morning, some of them it might not be. So we just normalize everything. So last time we went through this stuff here, through Chapter 1, Chapter 2, and we got through this, the programming assignment, actually. Yeah, that's correct. I was trying to look for the solution we did for this one. And I think I found it, but I wasn't sure why I didn't find a compiled program, because we definitely tested this on stream, but that's why it took so long, because I was trying to dig up some information, but then afterwards it took too long and I figured don't bother and just get on with it, because we're not going to be revisiting this too much anyway. So last time I think we got through some basics about how to store things, how programs are written, input and output, so writing to and from standard out, standard in, and also to files. And then next we're going to go into program flows, so looking into things like if statements and loops. And we'll probably end up doing Chapter 4 as well, we'll see. I'm not sure if we'll get to Chapter 5. But I did take a quick look at these, and these did seem a little bit shorter than the other ones, so maybe we'll get there. But anyway, continuing on. For those of you who don't know, Pascal is a pretty old programming language. It's still being updated today, and there's still, surprisingly, I think it was last year, it made it up to 9th on the TIOBE rankings. For most popular programming languages, so that was pretty surprising. I won't be paying direct attention. I need to get some important letters written and leave it in the background. Well, good luck. Always good to have a productive session. But here we go. Chapter 3, Sequential Control. I haven't talked in a week, so we'll see how my voice holds up here. Sequential control is simple. The computer executes each statement and goes on to the next statement until it sees an end. Which is pretty easy. I mean, that's how programs tend to go anyway. You go from begin, and then you go all the way to the end, line by line. I think I started trying to learn Pascal one time, though I didn't spend more than an hour on it. To be honest, I'm not entirely sure what the practical applications of Pascal is these days. Considering that it's 9th most used or popular or whatever it is on that index, people do apparently use it, but I personally haven't seen any jobs or anything that is asking for Pascal. But yeah, it used to be pretty popular back in the day, like the 80s and 90s, before Python came around, and then Python stole a lot of the actually, was it Python? C. I think Pascal actually predates C. It was something like that. But yeah, it's been around for a while. Boolean expressions are used to compare two values and get a true or false answer. Value, relational operator, value 2. The following relational operators are used. So we have less than, greater than, equal to being very, what is it? Unlike a lot of other languages, especially the C-like languages, Pascal only uses a single equals sign. And if you recall from last time, we learned that assignment is done with the colon equals sign, and so that's how this is differentiated. Whereas in C and C-like languages, you have the double equal sign being the Boolean equal to, and the single equal sign being the assignment operator. And that does tend to cause confusion to some beginner learners. But in this case, it's next to impossible to mix these two up. Unless you're coming from a C-like language, in which case sometimes you'll end up using this. But the effects of that is less catastrophic, because places where you would use the Boolean operators in C, it would also typically accept an assignment operator as well. But in this case, it wouldn't let you. So less than or equal to, greater than or equal to, those are the same. Not equal to, we have the double angle brackets. That's seen in a couple other languages. I think Basic. I think Basic uses that. I remember seeing something like that. What's the assignment equal in Pascal? So that's the colon equals. So that's the assignment operator. Yeah, instead of the exclamation mark equals in C-like languages, we have the double angle brackets. Complex Boolean expressions are actually, going back on this, the reason why this makes sense is because not equal to means that the value has to be less than, assuming we're talking about numbers, the value is less than or greater than, but not the same as the value we're checking against. Now, this maybe doesn't make sense if it's not a number, but same thought applies. Complex Boolean expressions are formed by using the Boolean operators, not AND or XOR, and in this case, just in Pascal fashion, you tend to have words instead of symbols. So it is a little bit more readable in some sense. Not as a unary operator, it is applied to only one value and inverts it. So not true is false, not false is true. Pretty self-explanatory. And then the same thing with AND or XOR. This is all stuff that we generally know from other languages too. XOR being here is pretty useful, I think. C-like languages don't have that, but it is the same as I think not equal to. So it is a little bit redundant, but it is nice having that for clarity. When combining two Boolean expressions using relational and Boolean operators, be careful to use parentheses. So we have 3 is greater than 5, or 650 is less than 1. Both clauses being wrapped in parentheses and then joined with an or. This is because the Boolean operators are higher on the order of operations than the relational operators, which is very interesting. Why are they higher on the... So in other languages, particularly C, or like C-like languages, the relational operators, or sorry, the Boolean, which one's which? Okay, this is the relational, this is the Boolean. The Boolean operators are less, have lower precedence than the relational ones. So I wonder what the thought process is behind this one. So 3 is greater than 5, or 650 is less than 1 becomes evaluated as 3 is greater than, and in parentheses 5 or 650 is less than 1, which makes no sense. Because the Boolean operator or only works on Boolean values and not integers. The Boolean operators and or not XOR can be used on Boolean values just as easily as they are used on Boolean expressions. Whenever possible, don't compare two real values with equal sign. Small round-off errors may cause two equivalent expressions to differ. And so this is true whenever you're working with any sort of floats. So that is fairly standard. So yeah, Booleans in Pascal seem pretty straightforward, except for this little bit here. But it at least means that it's going to be extra clear what you're intending. But yeah, I do have to wonder about this this decision here, where the Boolean operators are higher in precedence. Okay. If the if statement allows you to branch based on the result of a Boolean expression or operation. If expression, then statement 1, else statement 2. Where expression is any comparison constant or function which returns a Boolean value, and statement 1 and statement 2 are either a single statement, a begin-end block, a repeat until block, or the null statement. I actually don't remember what the null statement is. The empty statement, well, there's just a semicolon. Makes sense. The else clause is optional. There are two ways to use an if statement, a one-way branch or a two-way branch. The one-way branch format is if Boolean expression, then statement if true. If the Boolean expression values to true, the statement executes, otherwise it is skipped. The if statement accepts only one statement. If you would like to use a compound statement, you must use a begin-end frame to enclose the statements. So if Boolean expression, then begin, statement 1, statement 2, and. So this is the same, more or less the same as what you have in C-like languages, where the if statement does accept only a single statement, and if you need to have more than one statement, you use a compound statement denoted by the curly braces. A lot of people, when learning C-like languages, think the curly braces are part of the if statements and the other statements, but really it's just the it denotes a compound statement that has multiple statements inside. Mr. Welcome in. How's the calculator coming? Well, I haven't started programming that at all yet. I actually don't expect it to be this stream. It's probably going to be the next one, assuming that we get through the rest of the tutorial. Otherwise, it's going to be the one afterwards, because I don't expect this to take more than 3 streams to get through the tutorial. But yeah, we're learning about if statements. Earlier we had learned about Boolean expressions, which there's a little bit of a quirk to them, in that your ands and ors are higher precedence than your less thans and equals to, but I just have to keep that in mind. Two-way branch, there's a two-way selection. If Boolean expression, then statement if true, else statement is false. Note that there is never a semicolon immediately before the else. Oh, that's I get why, but okay. Maybe it makes sense to just use begin and end all the time. Semicolon here is mandatory, semicolon here is optional. Semicolon here is forbidden. Okay. I mean, it makes sense because if you expect a single statement here, then having it be terminated by a semicolon means you might have 2 statements or something, because you do have the null expression or the null statement too. I don't know. I don't know if I want to try to justify this decision here, but maybe it makes sense for parsing reasons too. If the Boolean expression values to false, the statement following the else will be performed. Note that you may never use a semicolon after the statement preceding the else. That causes the computer to treat it as a one-way select. Ah, oh, it is for parsing. Okay. leaving it to wonder where the else came from, and when a compiler wonders, it usually gets mad and throws a tantrum, or rather, it throws an error. Okay. Okay, no, that makes sense, because if statements don't have any end delimiters, so the only way you know is that it's terminated by the semicolon, and if one-way selection has no else, and the way you know that is with the semicolon, then that means that if you have a semicolon there, it sees it as one way and doesn't know what to do with this else here. I guess that makes parsing easier. If you need multi-way selection, simply nest if statements. Okay. This is the way it is in CLX too, where I wonder if it's actually common to use if then else. Maybe it is. I would probably format it that way. Even in C, I'm gonna open a new tab here. Say, right, even if you do this, else if else, what you're really saying here is, I'm gonna use another language here, close enough. What you're really saying here is, if you get rid of the, or if you add a pair of braces here, because this is quite literally what it is, it's just nobody thinks of it this way, or nobody writes it this way because it's redundant, but it is the same thing in C. Actually, let's lose the braces here. C and C-like languages. Yeah. So people write it like this, but it really is like this. Be careful with nesting. Sometimes the computer won't do what you want it to do, because you need a semicolon there. If condition 1, then if condition 2, then statement 2, else statement 1. That is because there's no semicolon here, so it will see this else as connected to this if. Else is always matched with the most recent if, so the computer interprets the preceding block code as this. This isn't Python, and the compiler doesn't care about your indentation. You can get by with a null statement. Okay. Wait a minute. Oh yeah, no. Semicolons are used in Pascal for. Oh, that's. I forgot. Semicolons are in Pascal. Semicolons are statement separators, not terminators. I'm vaguely recalling this. Hold on, I'm going to go back to the things here. Where is it? Program structure. Semicolon. Because I know there's a thing here somewhere. Identifiers. No. Assignment, operation, punctuation, indentation. There we go. Program heading, kite definition, all the. Where is it? Okay, whatever. I recall there being a point somewhere saying that the semicolons are separators, not terminators. I just don't remember where I read that. What do we have here? Or you can use a begin-end block. This is probably what I assume is going to be best practice. You just use begin and end wherever you have an if. Because I mean that's the way we do it in CLX, right? It doesn't matter if you have one. A lot of people will say use your braces always. just because it prevents surprises down the line. I don't necessarily subscribe to that, but hey, I can see the appeal for it. I'm actually okay with doing if cons statements like this. This is fine to me, but some people will say do this instead and just always have the braces. Following proves a semicolon is absolutely forbidden before an else. Compiler test program errors. We can try this out. All right, well, let's try that out. What do we call this one? Error 03.pass. And then we can compile that. FPC, we're using the freepascal compiler. And this should give us a syntax error. There we go. Expected, or semicolon expected but else found. Compilation aborted. And because we have a semicolon here where there should not be, so we remove this, then it should compile fine. Just like that. Reach part 1. Yeah, okay. But the best way to clean up the code would be to rewrite the condition. If not condition 1, then statement 1, else if condition 2, then statement 2. Which I do agree. If you have an empty empty block, then it's better to negate your condition. This example illustrates where the not operator comes in very handy. If condition 1 had been a boolean like not, I'm gonna move that over here, this way. Not a less than b or c plus 3 is greater than 6 and g. Reversing the expression would be more difficult than nodding it. Yeah. And it tends to be clearer if you just slap on a knot anyway. Also notice how important indentation is to convey the logic of program code to a human, but the compiler ignores the indentation. Yes. The compiler does not care for your spaces, except where they're necessary. Moving on. Case opens a case statement. The case statement compares a value of an ordinal expression to each selector, which can be a constant, a subrange, or a list of selectors separated by commas. Selector field separated to action field by colon. What does this mean? Selector field separated to action field by colon. So this here, the selector, and then the action. It's a bit of a weird way of saying that, but it makes sense. So this would be, as I gather, the equivalent of a switch statement in C-likes. Suppose you wanted to branch one way if b is 1, 7, 2037, or 5, and another way if otherwise. You could do it by if b equals 1, or b equals 7, or b equals 2037, or b equals 5, then statement 1, else statement 2. But in this case, it would be simpler to list the numbers for which you want statement 1 to execute. You would do this with a case statement. Case b of these, then statement 1, otherwise statement 2. So otherwise appears to be the equivalent of the default case in C-like. The general form of the case statement is case selector of list 1, statement 1, list 2, statement 2, list n, statement n, otherwise statement n, or otherwise statement. The otherwise part is optional. When available, it differs from compiler to compiler. Oh no, this is a language extension. Alright. We're using freepascal, so it should be fine with otherwise. But that is very interesting. Many compilers use the word else instead of otherwise. Selector is any variable of an ordinal data type. You may not use reals. So ordinal means that I assume here it means they're well ordered, which means they have discrete, distinct parts. So are strings ordinal? Maybe. Yeah, no, I think they are, because you can sort them alphabetically. Well, that should be fine. Note that the list must consist of literal values, that is, you must use constants or hard-coded values, you cannot use variables. Probably for optimization reasons. Because the way these things tend to be implemented is that they're implemented as jumps, where you compare them and then you jump. It's a lot easier to do that with constants. But okay. So language extension, where it's been long enough that this is more or less standard, except some compilers still use something else. Okay. Yeah, one of the things I've come across in the Pascal tutorial is that sometimes different compilers will do different things and have different syntax for them. Nowadays, it more or less almost doesn't matter because the modern compilers more or less support each other's, or at least freepascal. It supports all the other modes, generally speaking. But it does remind me a little bit of, say, a language like Prolog. Prolog has a similar problem, I think, where there are a bunch of compilers and sometimes there's some incompatibilities between them. I think I'm a little bit spoiled being in JavaScript, where there's a standard and everyone more or less sticks to it. And I don't think we get to see this too much in C either, although we do get some compiler extensions as well. But in terms of language like this, I think they're all fairly baked in already. But yeah, this is interesting. I guess, you know, being an old language, you get extensions like this when nice things pop up. For do loops. For do is a loop construct in Pascal. Of course, they may raise the question, what is a loop? Loops. Looping means repeating a statement or compound statement over and over until some condition is met. There are three types of loops. Fixed repetition only repeats a fixed number of times. Pre-test tests a Boolean expression, then goes into the loop if true. And post-test executes the loop, then tests the Boolean expression. So if we're looking in comparison with C-likes, this is a for loop, this is a while loop, and then this is a do while loop. And then some people will say that you shouldn't do this. I disagree. I think there are very useful situations where it's cleaner to do this, but there's also the I don't know what I would call it, where you test inside of the loop, where you have a break in the middle. In Pascal, the fixed repetition loop is the for loop. The general form is for index is starting low to ending high. Do statement. The index value must be of an ordinal data. The index can be used in calculations within the body of the loop, but its value cannot be changed. Count is 5 will cause a program exception. Okay, so this seems fairly sane. Most people wouldn't want to touch the loop index anyway. There are some cases in C-likes where it can be a little bit cleaner, but generally speaking, most people will prefer to avoid it. Will prefer to avoid doing so. So I guess ordinal here means that it should be numbers. In Pascal, the for loop can only count in increments steps of 1. A loop can be interrupted using the break statement. An example of using the index is sum equals 0, count equals 1 to 100, do begin, sum is equal to sum plus count. If sum is, I should stop saying equal to here. Assign sum plus count to sum. If sum is equal to 38, then break. Okay. Yeah, so that's interesting, having it only count in increments of 1, which means that if you need to do other things, like count in increments of 2, you're going to have to add an intermediate step where you do your mapping and transformation. In most cases, this is probably what you want, incrementing by 1. And so in that light, it makes sense. Let's say you're stepping through an array of some sort, which I think we did end up learning somewhere. I remember using arrays earlier. But yeah, if say you're stepping through an array, this makes sense because generally speaking, you're going to be looping through every element of the array. The computer would do the sum the long way and still finish it in far less time than it took the mathematician Gauss to do the sum the short way. 1 plus 100 equals 101. 2 plus 99 equals 101. See pattern, there are 100 numbers, so the pattern repeats 50 times. 101 times 50 equals 5050. This isn't advanced mathematics, its attribution to Gauss is probably apocryphal. I mean, if I'm not mistaken, it was Gauss the one mathematician where they said anything that was discovered by Gauss, they name it after the guy who discovers it next, because Gauss has a lot of things attributed to him. In the for to do loop, the starting value must be lower than the ending value or the loop will never execute. If you want to count down, you should use the for down to loop. Okay. So you can do decrements of 1. I am also kind of curious as to the thought process behind this, where you create, because other languages have a construct similar to this, where you have, I think Lua does this, where you have a start and an end, but then they also have an incrementer, where you can specify how much to increment or decrement every time. But it seems Pascal has opted to go with a second keyword instead, where they use down to instead of to go to decrement by 1. And you still have to do transformations if you want to do anything except for 1. Okay. Fascinating. While do. The pretest loop has the following format. While Boolean expression, do statement. The loop continues to execute until the Boolean expression becomes false. In the body of the loop, you must somehow affect the Boolean expression by changing one of the variables used in it. Otherwise, an infinite loop will result. A is assigned 5, while A is less than 6. Do write ln A. Remedy the solution by changing the variable's value. Yeah, so nothing writes to A here, which means A will always be 5 and it will always be less than 6. And you end up with an infinite loop. But instead, if you change A to increment it by 1 every time, then eventually A becomes 6 after the first iteration, which means it is not less than 6. Because 6 is equal to 6 and not less than, and so it'll break. The while do loop is called a pretest loop because the condition is tested before the body of the loop executes. So if the condition starts out as false, the body of the while loop never executes. I'm reminded, I don't remember which language this is, but I think there is this one language that has just a loop construct, and then you have to manually break you have to manually put a break inside the loop. So instead of having a while and a do while where you have pre-test and post-test, you just have a loop and then you have a break somewhere in between. You can put that break in the start, you can put that break in the end, or in the middle if you wanted to. But I wish I could remember which language that was, because that's, I think that if I were to design a language, I would probably do it that way. Repeat until. The repeat until construct is termed a post-test loop because the controlling condition is tested after each iteration of the loop. It has the following syntax. Repeat statement 1, statement 2, and further statements until Boolean statement, or Boolean expression. Okay, hold up. Notice how we don't have a begin and end here. So we have in the, we're gonna go back here. We have a while do loop that takes in a single statement. And if you want to add more statements, you have to use a compound statement with a begin and end. But in repeat until, it takes in multiple statements. I wonder if this is a language extension. A repeat loop encloses executed statements, which means they do not need to be further enclosed in a begin-end block. Note that a repeat loop continues until its controlling Boolean expression is true, whereas the while loop continues until its Boolean expression is false. Okay, so they flipped it. So this isn't a do while, this is a do until. I know some other languages, so for example, Bash in the Bourne shell has an until loop, where you have until some expression is true, which is to say while the expression is false, then you do this. Yeah, I don't know how I feel about this. Why would you? Does it make sense to flip the expression just because it's at the end? I don't know about that. I mean, I guess it makes sense in that if you consider it to be a break, then saying that this is basically if this expression is true, then break. So I guess if you think of it like that, logically it makes sense, and I guess that's why for the while loops you enter it only if the condition is true. Okay. It's not wrong. It's not wrong to have this. It is just a little bit of an interesting way of doing it. For instance, the following repeat loops executes at least once. So yeah, I do have to wonder how many times you'd end up having to use not in a case like this. So repeat write ln node.text node is assigned get next node until not assigned node. It assumes that node is not nil at the outset. If this assumption is incorrect, the code will fail and the program may crash. A while loop is more defensive, since the needed check is performed before any loop statements are executed. While assigned nodes do begin write ln node.text node is assigned get next node. Use a repeat loop when the looping statement must execute at least once, whatever the initial value of the controlling Boolean condition. It is not difficult to inadvertently write a Boolean expression controlling a repeat loop that never becomes true. This gives rise to an infinite or endless loop and causes the program to hang. One programming style deliberately sets up an infinite loop and inserts a break or exit instruction controlled by some condition evaluated in the middle of the loop to break out of the otherwise infinite loop. Statement 1, if condition, then break statement that might affect the condition until false. Yeah, this is what I mentioned before about having a test inside the loop. So I guess this is a little bit more elegant in Pascal syntax to do repeat until false rather than while true, because then at least you have repeat here, and then you don't have to use your begin and end. Use of the style depends on condition dependably becoming true without exception at some point. Otherwise, you have built an inescapable infinite loop. Okay. Yeah, repeat untils, I suspect they probably don't get used a whole lot, much like in C where do whiles don't get used a whole lot. But they can be useful. They're a tool in the toolbox. For in. This loop was added in Delphi in 2005, was introduced in freepascal in 2.4.2. Well, may as well have a look at this. So we have a language extension. This iterates over a collection, but where a basic for loop uses numerical index counter, a for in loop instead retrieves a collection retrieves collection elements into the counter variable for immediate use. So this is like the for each loop in many languages, or the for each equivalent. For in works on strings, arrays, sets, and any other custom collections that implements the required iterators. Looping over empty collection does nothing. The counter variable cannot be modified inside the loop. The for in loop construct, we said that. The official documentation is here. That's okay, we don't have to look at that. So we have a begin for C, the C being a character, in S being a string, do something. So doing a for in loop over a string loops through characters. Now, I would wonder if this is a Unicode character, or if this is a code point, or if these are bytes. I don't remember what the character type here is. Array loop, array of bytes. For B in A, so this is an array A of bytes, and every byte is going to be put into B as it iterates to something. I have to assume that this is a single statement, and you still have to use your begin and end if you want to have more statements. It's interesting that they don't put that here. But I assume you're probably expected to know this if you're looking at these pages. Type tcolor is this, tcolor set of colors. We learned this stuff last time. I don't know if I can write this without a reference. Procedure set loop. Var color, tcolor begin for color in colors. So tuples, tuples. You can also iterate over. Interesting. Okay. Fancy. Can't think of a language where you can do that. At least the languages that I think the languages I know. Well, I mean, the languages I know don't have tuples, so that's already a thing. Actually, JavaScript, there's a proposal to implement tuples as language primitives. I don't know where that's gone. But it would be kind of nice to have them. Loop variables are temporary copies of the container value. So the loop variable in a for loop is a copy of the value that is stored inside a container over which the for in loop is performed. What does that mean? So we have an array loop. We have pointer address, the same memory address as item 1. I did not know Pascal had pointers. Interesting. Then we have pointer int array is at I. So this points to this variable here. For I in array, that is this one. Print ARR. Pointer address, so this, yeah, so that points to this one. Is there anything here that is not obvious? I don't know what the alternative would be. Array is 0. Where is it assigning? So int array is separate variable that points to the first element. So we have a set length of int array. Okay, so we have this. So that's an array of 3 items, and we have p int array, which is a pointer to itself. What? Okay, sure. Int array is separate variable that points to the first element. Sure. Addresses of the single items, we have 0, and then 1, 2, and the array loop. I think it makes sense to just compile this and see what it's doing. What do I call this thing? Pointer array.pass. Okay, so what is this doing? So we have the global p int array address is this, and then we have the global int array address. This is the pointer, this is the array. Int array points to this, and you have item 1, 2, 3. So it points to the first item. Then after the array loop, this points to the array loop variable. Okay, I'm not entirely sure what this is trying to talk about, but okay. To traverse a container class, you need to add an enumerator for it. Enumerator is a class structured according to the following templates. So in a class here, there are only 2 things required for enumerator class: a move next method and a current. It's basically saying that for the thing to have an iterator, you need to implement this interface. I'm gonna skip that. Multiple enumerators. You'd have more than one. Interesting. Okay. And we have even more extensions. Okay. It is not possible to traverse either enumerator types or subrange types, where in freepascal we can write the following. This, you know, the range. Okay. I don't know if I'm starting to, I feel like if I need to use this, I can always go back to this. This is starting to go over my head a little bit. And we have even more proposed extensions. I assume there's no governing body for Pascal. And this is probably why we have this kind of extensions on extensions. Five through 9, welcome in. We have gone through Chapter 3, most of Chapter 3 actually, the branching and loops, and then while detour on 4 in loops, which, as we've learned, is a bit of an extension over extensions situation. Solly, welcome in. But yeah, it's I don't know. As I said, I don't think there's a governing body for Pascal. There are standards. I can't remember if they're IEC or RFCs, but there are standards. But the compilers seem to be just doing whatever they want. Okay, programming assignments. Find the first 10 numbers of the Fibonacci sequence. Fibonacci sequence starts with 2 numbers, and each subsequent number is formed by adding 2 numbers before it. This forms the following sequence. This. Okay. We can do that. I recall actually, I had a technical interview when I was in university, where they asked me to do the Fibonacci sequence in some language, and I knew how to do it, but for some reason I struggled with actually programming it. So program Fibonacci. As we recall, Pascal programs all start with that, with a program statement. I guess they're capitalized, typically. And then you start with your constants and your variables, which I think we're going to skip the constants because we don't need those. We do have variables. A is number, int. Integer. It's been 2 months. We're gonna start with B as an integer. Actually, we can say A and B as integer, and combine them that way. Begin, end with a semicolon, because that's how this goes. No, with a dot. And so we can say that. Actually, we'll have a const. We'll have const n as an integer. Let's say we give this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're just going to assume this is less than... we're going to assume that... For now, we're going to assume that it's not going to be less than 2. Actually, hold on. We can build up to that. So we have a for loop for I assigned 1 to n to begin, end, what is this? I think this is where I maybe got stuck. We're printing B, I think. Print write ln write. I'd already forgotten what the okay. The convention for this is lowercase. Write ln. Let's say a. For I equals 2 n, do write ln b, and then we can say a is equal to b, and b are... Do we need a holding space for this? I'm gonna have a container here. C is equal to a plus b. A is equal to b, and b is equal to c. Right? That's how you do Fibonacci, right? Except we need the begin up here. I don't program anymore. Whoa, identifier not found because I need to declare it. Variable A does not seem to be initialized. You're not wrong. A equals 1, B is equal to 1. Syntax error. Expected, but identifier A found. Wait a minute, hold up. I forgot. Variables start with variables start with capitals? Is that the convention? This is why you don't go 2 months between sessions. I think the convention, I don't know if it matters actually, but yeah, I don't think it matters. I don't remember if it matters. Or we're gonna make this uppercase anyway. $17. Oh yeah, I forgot to say. Okay. What if we just don't? This uppercase here looks kind of weird. And I realized I could have probably just pressed undo. Does this work? I guess it does. It's not exactly what it says here, but like it says to put it in one line. I don't really care. This is not a formatting exercise. This is an exercise in doing. What am I saying? This is an exercise in loops. So actually, we can get rid of this. We can turn this into 1, and if you turn this into 0, then you should be able to get this without having to do that first right. You get 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and 144 looks correct. I will call that a pass, even if it's not in one line like this. Because it doesn't say properly formatted, so it's fine. This one I think we will need to format. I don't understand the formatting though. Oh, 5 numbers per line, but there's this little space here. Okay. Actually, I wonder if this is a problem with transferring to the wiki, because we look at the source for this. Yeah. Is that correct? Oh well, that's fine. I'm going to assume these spaces aren't here. Display all powers of 2 that are less than 20,000. Display the list in a properly formatted manner with commas between the numbers. Display 5 numbers per line. The output should look like this. So I think the easiest way maybe is to generate powers of 2. Program. Power 2. The easiest way is probably to actually hold on. No, maybe not. Maybe not. This is. I was gonna say generate an array and then print the array, but we can actually just do this linearly. And so then the question is, how do we write the commas and how do we write the spaces? Let's deal with that later. We have var, we have const. I'm going to say limit is equal to 20,000. And var, I don't know why Vim is not respecting my indentation here. We have var n. Yeah, let's call it n. This is an integer. Begin, end, with a dot. And then we can say, while n is less than limit, do, alright, this isn't bash, whoops. Do begin, end. What do we want here? N is equal to, we start with 1. Yes, we start with 1. Then we write, we just do a write, we write n, and then we say if n, or if we also need a count. Count is equal to integer. We initialize count to 0, or count to 1. Count to 0. We're going to start with 0. If count is equal to 0, if not, count is not equal to 0, is greater than 0, then we write a comma. Then we write a comma. Wait, hold up. Pascal uses single quotes, right? Yeah, Pascal uses single quotes for his strings. We write a comma, and then if count is not okay, I'm gonna walk through my thought process here. I'm gonna say if it's not the first one, then we write a comma. If it's divisible by 5, then we write a new line. No, that's not right. This is 1, or this is 0. This is 1, 2, 3, 4. This actually has to come first. So if count is greater than 0, then we write comma. If I think we need to begin, and just so we can have multiple things here, we write a comma, and then if count is, do we have a, oh, I need a mathematical operator, the mods, where is, I need remainder mods, there it is. If count mod 5 is equal to 0, I don't think this is correct. But we can deal with that afterwards. Iterative programming. So if it is, then we use a new line, else, and we remember not to have a semicolon there. Because otherwise Pascal doesn't know that you want an else. But you do need a semicolon here. Actually, I think it's optional if you have it, if you don't have it here. Do you typically do... I don't remember if you typically have semicolons after the ends. I guess we'll find out. So we can have a look at some of these ones. Not this one. Yeah, okay, they do have semicolons at the ends. Okay. Oh, this bothers me a little bit. Now, the question is this wrong? Actually, I'm going to just make this the right ln and then have this. FPC powers. We're going to have a compilation error because I'm sure I forgot something. Expected, but assignment found at 4. Really? Right, I think I might have said something about that last time. So in this cons section, you have assignments. Hey, is it really assignment then in that case? You use the equals sign instead of the colon equal sign for assignment inside of the cons section. 28. Do I have a straight end somewhere? Probably do. Yes, that. Because I don't need one for the else because the semicolon here terminates the else. Oh, infinite loop, alright. What are we missing? I did not increment counts. +1. I need to recompile. And that's still wrong. Oh, right, because I need to, n is equal to n times 2. Gotta change the n, too. FPC. I feel like syntactic distinctions like that just mean more work for the novice than for the compiler. Yeah, I wonder if it's a parsing thing. Because a lot of the times when you have weird syntax like that, it usually, for some reason, results in... or it's often because it simplifies parsing in some way. And given Pascal is an old language, having a simplified parser could have been beneficial. But it is a little bit odd coming from a modern perspective. Okay. Where is the bug here? N is equal to 1, n times 2. So while n is less than limits, limit here is 20,000. Do begin count if count is greater than 0. So we skip this for the first one. We write n, so that's 1. Count is incremented by 1. And then n is multiplied by 2. And then this n starts there. And this n ends the entire thing. So we are getting the commas. Yeah, I know it's why a lot of C syntactic iceberg is the way it is, but in some cases I would expect such rules to increase complexity. Yeah, perhaps. Yeah, I don't remember. No, it's Pascal. I'm pretty sure was after the punch card era, so I don't think that. Maybe it was. I don't know. I know it was pretty close to. It was contemporary to some of the languages there, but I don't think it ended up being actually punched onto cards. Because in that case, if it were punched onto cards, then the number of characters would be significant, but yeah, I don't think Pascal. I think Pascal was made afterwards, so it couldn't be that. Okay, we're gonna start writing a bunch of debug statements here because I don't know what's going on. Write ln debug 1. I'm forgetting how to write stuff. Actually, we don't need this because we already have that. Debug 1 is counts. Debug 2 is n. Debug 0. Can I do this? Apparently I can. Okay, so what's wrong here? Why are you doing this? I forgot spaces. Give me my spaces. Sometimes there's a vibe of this was specified based on the exact behavior of particular careless but usable implementation. Yeah. Yeah, that does happen sometimes too. Okay, so we have one, debug 1, debug 2. I'm gonna count. Let's make these actually readable. In loop. Count 1 and n is 2. No, that makes sense. So n is initially 1 and then is 2. And then inside you have n is 2 and count is 1. Because you're now in the second iteration. So you write the comma, you write the space, and then count is 2 because it increments it. And then debug n is 4. Why are you not writing anything? Oh, wait, no, you... 2, you write 2. Okay, no, this is working correctly. Hold on. This is working correctly. Yeah, there we go. And then it overflows. Why do you overflow? Oh, wait a minute, hold up. Okay, how do I want to fix this? Is this, and n is greater than 0? Just to catch the overflow? I feel like this is not the right solution. But it does overflow, that's just it. And we run into the thing again where we, where the relational operators and the Boolean operators, the Boolean operator has a higher precedence than the relation operators. Okay. Or there are a bunch of edge cases that you wouldn't expect anyone to actually write, but a particular compiler happened to interpret them in a particular way. Oh yes, reminds me of the the situations where the compilers basically dictate the spec, and then that gets encoded later. Happens in browsers, happens in subtitles. There we go. That's what you want. I don't think this is the right solution, but it works. Surely there's got to be a... There's got to be a different way to do this. I think when you get the solution here, so we'll see. We have Fibonacci 1 and 2, we're gonna temp and we're gonna count. Right, Fibonacci 7. I mean, that's not specified in the format, but that's okay. It's not specified in the format, which means I can print it however I want. But this does look like... Alright, let's have a look at this link here. Oh yeah, we'll actually, no, let's do this first. And then, so yeah, this I think is more or less what we wrote for Fibonacci, because that is... So we have the temp... They did it a different way, but it's the same thing. Basically calculate A plus B, and then you have A, you have C. And then you have this, put that in a temporary variable. And then you have count is count plus 1. Why wouldn't you just use a for loop? Of course you could use a for loop or a while loop to solve this problem. It makes sense to me to use a for loop here because you are going sequentially from 1 to n. Okay. 5 per line, original version. So max num, num per line. Oh yeah, I guess this should have been a. That makes sense to have these as constants. Yeah, because right now they're just magic numbers. Oh, it's a long int, right? Because sizes are a thing. Okay, that there is the correct solution. But if you were to have just a regular integer size. So for those of you who aren't familiar with this here, long int basically has more room for numbers to grow. And so if you hit 20,000, it's actually 20,000 and it won't overflow to the negatives. Line count is line count plus 1. Print a comma and a space unless it's the first number on the line. Yeah, I guess that's a decent way of putting it. So if line count is greater than 1, write this, and then you display the number, print a comma, and go to the next line if this is the last number on the line, unless it is the last number of the series. See, this is what I wanted to try to avoid. All this nonsense here, but I guess I had to have done something similar anyway. It's just here I say if this is the first one, don't print a comma or a space or new line. Otherwise, everything afterwards gets preceded by a comma and either a space, or if it should be the first one of the line, it gets a new line. Otherwise, it gets a space. Whereas this is trying to do print a comma and go to the next line if this is the last number on the line, unless it is the last number of the series. Actually, we can simplify this, because this can be that, and this can be that. This is what I submitted, so I'm going to leave it at that. But this is a probably cleaner, a slightly cleaner solution, maybe, just because it's one fewer line, perhaps. But yeah, interesting. And then you increment that. Wait a minute. Number times 2 is less than. Why would you not use the base constant that you used here. Line count is num per line and not number times 2 is greater than max num. Yeah, why wouldn't you use the base here? So I think this is supposed to be using base. And then write ln this line count. So this I don't agree with, because it means that you're calculating the number twice. You're doing a pre-calculation where you should ideally only be doing it once. And then increment the number and while write ln. This program can also be written as a repeat until loop. Sure. Which I don't think a repeat until loop makes sense, just because if your limit is lower than your n, then you don't want to enter this at all. So in this case, I think the while loop is more correct. Of course, you could use your Fortran to write this program, yeah. Okay, so let's have a look at this HTML spec here. For historical reasons, the value IDL attribute prefixes the file name with the string C fake path. What? Hold on, what is this? This is for the input file upload. Some legacy user agents actually included the full, let me make this larger. With the full path, actually included full path, which was a security vulnerability. As a result of this, obtaining the file name from the value IDL attribute in a backwards compatible way is non-trivial. The following function extracts the file name in a suitably compatible manner. If path of substring is C fake path, then you do this. Okay. Interesting. Yeah, there's a lot of these kinds of nuggets in the HTML spec. One of my favorites, I think, is the HTML DDA. HTML document.all. So document.all, I can find this one, sure. Document.all is a property that was implemented in Internet Explorer, and only Internet Explorer. And web authors had used this as a way of seeing if the browser running the code was Internet Explorer, because only IE had this. But then it was implemented in the standard that says it should influence the actually I can demonstrate this. Dock to bottom. Make this a little bit larger. Document.all. So it's an HTML all collection. It has all these properties in it. But if you do type of document.all, you get undefined. Date.prototype.getYear is one of my favorites. Yeah, that was another one too, because getYear only had a 2-number or 2-digit year, and then getFullYear is the is a preferred one now, because now that gets 4 digits. So I don't know, because Java, this was all based on Java, and they were in the 90s. And so I don't understand how they didn't think of Y2K. I feel like in the mid-90s you don't have an excuse for introducing Y2K vulnerabilities. Yeah, I don't know what happened there. But yeah, document.all is a falsy value. So if you do boolean document.all, it is false, but you can't actually access anything that's in here. So document.all 0 is a thing. And actually, let me this reminds me of a of an old programmer anime. Let me see if I can find it. Programmer enemies. I'm gonna find the thing first and then show it on stream. Author Bucket 3432. He's the one who made this one. Ah, it's called document.all. Alright. Yeah, exactly this. Browser compatibility is fun. Honestly, all the browser API collection types are a mess in terms of the exact things they do or don't have in common with arrays. Yeah, I mean that's a whole other thing. The DOM collections, the reason it's like that is because the DOM is specified for not just JavaScript but other languages, and other languages may or may not be as flexible as JavaScript is in terms of their collection types. So they can't be specifying from a technical standpoint or a specification standpoint, they can't be specifying things like maps and loops and whatnot because, or rather, they have to specify it built in to the interface or something for compatibility reasons with other languages. But you could make the argument that you could still be to spec and then also be idiomatic in the language, and I think that would make sense, but yeah, I guess it's not the way they opted to do things. It'd sure be nice if we could actually practically use other languages in this day and age. Well, I mean, if you parse an HTML document in another language, you do get a DOM out. It's just working with that DOM in that language is something you'll have to figure out. But it is, well, you can't use it on the web, but you can parse the HTML and stuff and work on the DOM that way. Does anyone do that? I don't know. I mean, people do write web servers in Python, so it is maybe a thing, but I don't know how many of them actually do stuff like parse HTML. Well, back to this though. Note that I use 3 constants to base the number of powers to display on each line and the maximum number. This ensures that the program can be easily adaptable in the future. Using constants rather than literals is good programming habit form. Yeah, so as I said earlier, the 5 here is a magic number, and the 2 here is a magic number. And so those would probably be best as constants. When you write really long programs, you may refer to certain numbers thousands of times. If you hard-coded them in your code, you'd have to search them out. Also, you might use the same value in a different context, so you can't simply do a global search and replace. Using a constant makes it simpler to expand the program. Also note that I use the long int type for the number variable, as we found out why. This is because to fail the test number less than or equal to 20,000, the number would have to reach 32,768. The next power of 2 after 16,384. This exceeds the range of the integer type, which is this. Try it without long int and see what happens. We already did. But yeah. Yeah. So that is chapter 3. I'll move on to chapter 4. I think we still have ample time. Procedures. A procedure is a subprogram. Subprograms help to reduce the. Actually, let me. I'm going to remove error. I'm going to ignore error 03 because that is not written by me. So we error 03.pass to .get info exclude. And now we can. Hello? Did I do this wrong? Git status, hello? This should be, did I write this wrong? ERR03.pas. ERR0. I will debug that later. Add programs for chapter 3. Somebody figures it out before I do, then let me know, but that is odd. For anyone who hasn't seen this before, git info exclude is the repo local git ignore. So normally you'd have a git ignore checked into your repo, but if you don't want to touch, if you don't want to have it ignored for everyone, and you want it just for this repo, you can add a line to this file here, and it'll exclude it just for you on this repo. A procedure is a subprogram. Subprograms help to reduce the amount of redundancy in a program. Statements that are executed over and over again but not contained in a loop are often put into subprograms. So this is basically our equivalent of functions in other languages. Subprograms facilitate top-down design. Top-down design is the tackling of a program from the most general to the most specific. For example, top-down design for going from one room to another starts out as get out of first room, go to second room, go into second room. Then it is refined to get out of first room, go to door, open the door, get out of door, close door, and so on. Just going to the door can be refined further. Get out of first room, go to door, get out of seat, turn towards door, walk until you almost bump into it. This, of course, can be further refined to say how much exercise should be given to your cardiac myofibrils and how much adenosine diphosphate should be converted to adenosine triphosphate by fermentation or aerobic respiration. This may seem to be too detailed, but for computer programming, this is in effect what you have to do. The computer can't understand general statements, and you must be specific. I know what some of these words mean. This is ATP. I remember the Krebs cycle. Can I actually tell you anything about it? Not really. Like in terms of the actual process, not really, but it was a thing I think we learned in high school biology class. Main tasks should be contained in procedures, so in the main program you don't have to worry about the details. This also makes for reasonable code. You can just keep your procedures in one file and link that into your program. A procedure has the same basic format as a program. A procedure name, const var, begin, end. There is a semicolon, not a period at the end. Oh. Here we go again. Which I guess makes sense considering the period is a program terminator and the procedure is not the end of a program. To call a procedure from the main program, use just the name like you would write ln. Yeah, because I think these are all put in the same file. So it makes sense. It makes sense not to have a dot. Program procedures are very often used to output data. It's that simple until the next lesson, of course. A parameter list can be included as part of the procedure heading. The parameter list allows variable values to be transferred from the main program to the procedure. The new procedure heading is procedure name, formal parameter list. Oh, I'm just gonna get a drink. When you're talking for a whole lot, it's important to hydrate. The parameter list consists of several parameter groups separated by semicolons. I guess that makes sense considering you have commas for, oh wait, groups? We'll read on. We'll read on. The procedure is called by passing arguments, called the actual parameter list. Actual parameter list. You don't just call these parameters and these arguments like everyone else does? Of the same number and type as the formal parameter list. I mean, formal and actual, yeah, yes, I guess, yes, sure. Suppose you call the above procedure from the main program as follows. Alpha is assigned 30, name called with alpha 3, 4, and 5, where you have alpha 3, 4, and 5. I don't know how I feel about this. It's in every other language that I know. Now, not to say that it's invalid to do this, but I think every other language that I've worked with that has type specified for their parameter list has each parameter typed and not combined like this. I mean, I guess there's nothing stopping you from doing that in Pascal 2. I just don't know what the idiomatic pattern is. Whether people actually do this, or if they've migrate is not the right word. If they've tended to start separating them. But this does save on typing, which save on typing and save on characters, which I guess back in the day might have been valuable because hard drives weren't that big. Maybe. Suppose you called the above procedure from the main program as follows. This: when you return to the main program, what is the value of alpha? 30. Yet alpha was passed to A, which was assigned a value of 10. Yes. Okay. Yes. This works like in other languages where this is basically a separate variable. What actually happened was that A and alpha are totally distinct. The value in the program was in the main program was not affected by what happened in the procedure. This is called by value. This passes the value of a variable to procedure. Another way of passing parameters is called by reference. This creates a link between the formal parameter and the actual parameter. When the formal parameter is modified in a procedure, the actual parameter is likewise modified. Call by reference is activated by preceding the parameter group with a bar. I feel like I want more explicitness out of this, but okay, sure. In this case, constants and literals are not allowed to be used as actual parameters because they might be changed in the procedure. Here's an example which mixes call by value and call by reference. Surely there's some sort of best practice regarding this. So A and B are integers. These are passed by values, so anything that's copied into them are copied, and A and B are distinct variables. Whereas C and D they're basically a pass-through to the variables that are passed into them. Yeah, I guess this is kind of like C++ references, and you have similar patterns with C++ references and C pointers in that case. Oh, I don't like how that doesn't affect the syntax at the call site. Yeah, that's what I'm a little bit uneasy about, but I don't know, C++ does that, right? You say that this is a reference. Oh, no. Actually, hold on. In C++, I think you say... You use an ampersand? No, I think in C++ you have it at the... you have it at this level. At the at the parameter level, not the argument level. But it's been a while since I've touched that. C++ tripped me up there when I was contributing each. Okay, yeah. So it requires you to know that that's the signature. Except when I was cloning an entire vector. Immediately after the procedure had been run, gamma has a value of 3 because C was a reference parameter. But alpha is 1 because A was a value parameter. So we assign 3, and this is effectively a pass-through, so gamma gets assigned 3. But A has a buffer, and so alpha stays 1. I should probably not be using those terms that lightly, but it gets the idea is there. This is a bit confusing. I guess anyone who's not familiar with that, sure. Think of call by value as copying a variable and giving the copies to the procedure. The procedure works on the copy and discards it when it's done. The original value is unchanged. Call by reference is giving the actual variable to the procedure. The procedure works directly on the variable and returns it to the main program. In other words, call by value is a one-way data transfer, main program to procedure. Call by reference goes both ways. Sometimes I kind of wish JavaScript had call by reference, or sorry, like pointers and references and whatnot. You can get around it by using objects though, so it's not a total loss. But also, doing things that way is a little bit weird anyway in idiomatic JavaScript, so it's generally not done. But yeah, if we think of this as C or C++, that makes sense. It's just you have to actually, as C++, I think is the best comparison there. Functions. Functions work the same way. Okay, so they actually are different. So procedures do things, and functions return things, or do things and return things. Is there some sort of parsing benefit you get from differentiating the two? Or some sort of compiler optimization that you can do? Because otherwise, I mean, I don't know. All the other languages that I know have one type for functional procedures. So this is the fact that they differentiate between the two is interesting, because they don't affect how they're called. The only thing you can do with a function that you can't do with a procedure is you can use them in expressions like this. And so perhaps in a way, because you can use them in expressions, a function call is an expression type, whereas a procedure call is a statement, and the compiler can differentiate the two when parsing and give a compilation error. Maybe I'm going to say that's probably why. Now, C# is the only language I'm familiar with that has a Java-inspired memory model but doesn't have that shortcoming. I see. I don't know too much about C#. I might have to look into that. If your function has no argument, be careful not to use the name of the function on the right side of any equation inside the function. That is... Oh. Why would you even do this? Why would you name a variable the same name as your function? Like, is this even allowed? Instead of returning the value 3 as might be expected, this sets up an infinite recursive loop in language models. Wait. What does this even do? What does this mean? And what do you even hold on? What do you even return? Is there a next? You don't even tell us how to return from a function. Okay, I'm going to assume in the absence of a return value here, the last. Some languages do this, where the last expression. Wait a minute, hold up. Why is there a period here? Anyway, in the absence of a return value or a return statement, I'm assuming Pascal says that the last expression is the return value, and some languages do that. The return value is set by assigning a value to the function identity. Wait, is that what it says? Return value is set. Oh, right there. I have never seen a programming language do this. Other modes require brackets for function calls, even though brackets are empty due to no parameters being required for the particular function. Name will call name, which will call name, which will call name, and so forth. Pascal, technically? I don't remember enough about Pascal to remember how it does that. So yeah, the return value is set by assigning a value to the function identifier. What inspired this? Now, if you think about how this compiles down to low-level code, this kind of makes sense because the function call, when you jump to a different part of the code, when you return back to the calling code, you effectively, the registers are all still there, and your return value is whatever is specified in that specific register. And so in this case, it makes sense if you look at it from a low enough level. But this is coming from a modern perspective. This is very weird. Add AB is equal to A plus B. I guess if you look at it that way, but I see that more as a I don't know, less assigning to its identifier and more this is a function declaration or function signature, and then this is the body where it has an implicit return. And then the assignment there is this is the body to, or the body of the function is equal to this. But I suppose if you really wanted to look at it that way, you could call it assigning the no, but that doesn't. Oh no! You can still look at it that way in Haskell because Haskell is lazily evaluated. So, yeah, I guess you could look at it that way. It is generally bad programming form to make use of var parameters and functions. Functions should return only one value. You certainly don't want the sine function to change your pi radians to 0 radians because they're equivalent. You just want the answer 0. Are you suggesting that functions can return more than one value? Unless they're saying you can return more than one value through the use of var parameters, which you can do in procedures. Okay, so in this case, the distinction between procedures and functions kind of makes sense, because if this is the way you're going to return values, then you need to know that you need to know that this is a valid construct. I assume that if you tried this with a procedure, it's going to fail because name would not be assignable. Still very odd, but okay. Scope refers to where certain variables are visible. You have procedures inside procedures, variables inside procedures, and your job is to try to figure out when each variable can be seen by a procedure. A global variable is a variable defined in the main program. Any subprogram can see it, use it, and modify it. All subprograms can call themselves and can call all other subprograms defined before it. This is what I've been wondering about actually, because we see in this program we have these are all globals. But at least in modern programming, global variables are somewhat frowned upon. So it makes sense to scope things to where you need it, but I haven't seen anything, at least so far into the tutorial, to suggest that we can go with a tighter scope, which I guess we're covering now. The main point here is with any block of code, procedure, function, whatever, the only identifiers that are visible are those defined before that block and either in or outside of that block. So we have the program, we have var A, so this is a global. You have procedure, scope inner, so we have variable A here, visible to only this the scope here, shadowing this there, and then begin A, 20, so that's referring to this here, right ln A, that's this one here. Scope inner, this writes 10, and then this should write 20. Every program has an appropriate amount of global state which is often small but non-zero. Yeah. Some have a less appropriate amount, but yes. The reason is, if two variables with the same identifiers are declared in a subprogram and the main program sees its own and the subprogram sees its own, not the main's. So there's a concept of shadowing. The most local definition is used when one identifier is defined twice in different places. Rephrased, for every program there is an amount that would be appropriate. Yeah, so then that would be a better way of putting it. Here is a scope chart, which basically amounts to an indented copy of a program with just the variables minus the logic. By stripping away the application logic and enclosing blocks and boxes, it is sometimes easier to see where certain variables are available. You have program scope, ABC, those are global. You have procedure alpha, which has AFG. They don't even use the same example, okay. Procedure beta, VCR beta max cassettes, procedure 1 beta failure, and function beta 2 failure 2. Everybody can see global variables A, B, and C. However, procedure alpha, that would be this one, the global definition of A is replaced by the local definition, so A is shadowed. Beta 1, beta 2 can see variables VCR, beta max, and cassettes. That's here. Beta 1 cannot see variable failure 2, and beta 2 cannot see failure because they are in separate scopes. No program except alpha can access F and G because these are local to alpha. Procedure beta can call alpha and beta because you can see it from the outside scopes. Function beta 2 can call any subprogram. Oh, hold on. Sorry. Alpha is a global function, or global procedure. Beta is a global procedure. Function beta 2 can call any subprogram, including itself. The main program is not a subprogram. Beta 1 cannot call beta 2 because beta 2 has not been defined yet. How do you do co-recursion? Surely that's a thing you can do in Pascal. Okay. Our home server crashed and now I can't turn on my kitchen lights. Ooh, good luck. That doesn't sound good. Well then, we have recursion. Recursion means allowing a function or procedure to call itself until some limit is reached. Or don't have a limit, if you would like it to run forever. I can't remember if Pascal has proper tail recursion. If it does, then you can actually have it run forever without it crashing, running into a Stack Overflow. Function summation num integer returns integer. If begin if num equals 1, then summation is 1, so it's return 1. How do you do early returns? Is that another thing you can do? Because if you assign to... Oh no, okay. If there are no early return... actually, hold on, breaks work. Break out of a begin and end work, I think. Maybe. We'll have to maybe give that a shot. But I think break does work out to break out of a block. So that should give us a way to do an early return. So begin if num equals 1, then summation equals 1, so there's a return 1. Else summation is equal to, or is assigned summation num minus 1 plus num. So you do the number plus the sum of all the numbers before it. Suppose you call call summation for 3. A is assigned summation of 3. Summation becomes summation 2 plus 3. Summation 2 becomes summation 1 plus 2. At 1, the recursion stops and becomes 1. And then summation 2 becomes 1 plus 2 plus 3. And we can just go up the stack here. Or down the stack. Summation 3 becomes 3 plus 3 equals 6, and A becomes 6. Recursion works backwards until a given point is reached, at which an answer is defined, then works forward with that definition, solving the other definitions which rely upon that one. All recursive procedures, a function should have a test to stop the recursion, the base condition. Under all conditions, the recursion should go deeper. If there is no base condition, the recursion will either not take place at all or become infinite. In the example above, the base condition was if num equals 1. Now, basic recursion. I had never had an issue with understanding recursion, but a lot of people do, and I think it's because they try to unroll the entire recursion, and when you do that, you start hitting infinities. And it becomes difficult to process. But if you don't expand it, then I think it's a little bit easier to think about. Forward referencing. Ah, okay, here we go. This is how you do code recursion. After all these confusing topics, here's something easy. Remember that procedures functions can only see variables in other subprograms that have already been defined. I'm not sure they explicitly said this, but okay. Well, there is an exception. If you have two programs, each of which calls the other, you have a dilemma that no matter which you put first, the other still can't be called from the first. To resolve this chicken and the egg problem, use forward referencing. So basically you pre-declare the procedure, and then that means that the other procedure can see it. This is not a problem in languages like JavaScript because the entire file is processed before it starts, before it gets executed. But in C and similar languages, while it's not the case where it's where you have definitions being hoisted, you do have the way the compiler works is that it doesn't back-reference, it doesn't hoist any of the declarations, so you do have to forward declare things, and it seems like Pascal is similar in that respect. Gotta make a single pass. Yeah, in university, one of our courses got us to write a compiler, and the reason having this kind of model makes it easier is because you have to have a list of identifiers, and if you encounter an identifier that you don't recognize, it's very easy to just say this isn't valid, and you can throw an error. Whereas if you do hoisting, you have to do one pass first to find all the declarations, and then you go through it again to do your actual parsing, and then that's when you know that things are valid. So single pass compilation or single pass parsing is a lot simpler. The same goes for functions, just stick a forward at the end of the heading. So we declare the parameter list here, and then we don't have to repeat ourselves down here, which is nice. Whereas I think in C and C++, you still have to do the parameter list down here. And that's why we have C and C++ header files, because those have all the forward declarations, so that other modules can use them. Whereas if you had them just in the files, then you're stuck with this, or you're stuck with it being sequential. Programming side, aha, here we go. Yeah, classic recursion problem taught in all introductory computer science courses is the Towers of Hanoi, and indeed this was the program that I had learned recursion from, but it was through a book, because I had read about recursion before being taught in class. It might have been Code Complete by Steve McConnell, possibly. Code Complete, Steve McConnell. Oh no, if I can spell that, I don't think that's correct. It'll correct me. Oh no, I was right the first time. Yep. So yeah, this book here. There's a second edition now. I had read the first one. There's a cone-shaped tower on the leftmost peg, consisting of a series of donut-shaped discs. For example, this is what a 4-story tower looks like. Pegs are designated 1, 2, and 3 from left to right. The challenge is to move a tower any height from peg 1 to peg 3. In the process, no large disk may be placed on top of a smaller disk, and only one disk, the topmost disk on any peg, may be moved at any one time. The problem seems trivial, and it is for 1 or 2 disks. For 1 disk, you simply move it from peg 1 to peg 3. For 2 disks, move the topmost disk from peg 1 to peg 2. Then 1 to 3, and finally move the smaller disk from 2 to 3. The problem gets harder for 3 or more disks. For 3 disks, you'd move 1 to 3, then 2 to 1, then 3 to 2. This effectively creates a two-story tower on peg 2. Then move the large disk 1 to 3. Now move the 2-story tower on top of the large disk 2 to 1, 2 to 3, and 1 to 3. I feel like I need visuals here to explain this. Towers of Hanoi. I think we did. Yeah, no, we'd done this in a previous programming stream, I think. So basically, what it's saying is, for 3 disk, you do this. So you move the towers here, you move the large disk over there, and then you move the tower back on, like so. Your mission, should you choose to accept it, write a program using a recursive procedure to solve the Towers of Hanoi for any number of disks. First, ask the user for the height of the original tower. Then print out step-by-step instructions for moving individual disks from one peg to another. For example, a 3-disk problem should produce the following output: 1 to 3, 1 to 2, 3 to 2, 1 to 3, 1 to 1, 2 to 1, 2 to 3, 1 to 3. As stated in the section on recursion, Recursion is one of the more difficult topics to grasp. Some people will look at this problem and find it extremely easy. Others will have a difficult time with it. However, once you get past the hurdle of understanding the recursion, the actual coding of the program is relatively simple. So if you'd like to challenge yourself, stop reading right here. If you have a little bit of trouble, keep reading for a small hint. I've implemented this a number of times. So the trick here is, from what I said earlier, you look at the bottom one, and the way you think about it is you move the tower that's on top of the bottom disk to the temporary one, and then you move the bottom disk to the target, and then you move the tower back to the target. But to move the tower, you have to do that recursively. So the target for the second one here is going to be this one. So I move to the temp, move to the target, and then move to the target here. If you have odd in the leftmost peg, you start by moving its top disk to the rightmost peg. If you have even in the leftmost peg, you start by moving the top disk to the middle peg. This actually consistently works for any n. Yeah, so that's that is how it ends up being. But you do still have to program the rest of it. But yeah, that is how you would know just by looking at it which one you start with. Yeah, and so then the target for this tower now it moves to here. This is your temp, and then you move this way. And then same thing with 4. And we're going to test it out with this visualization here. Tower of Hanoi is why speedrunning the island Dr. Brain is so boring in the beginning. I think I've heard of that. I don't remember what it is. But yeah, so this is this way, yes. Like that. Alright, welcome in. I know this game. Yes. We're going to be programming it now. So we need to write a program in Pascal to output the steps for what we need to do for to solve the program, or to solve the puzzle. It's a point-and-click edutainment game with a bunch of different puzzles made by Sierra. Why am I not surprised it's made by Sierra? They do a whole, they do a lot of those. Okay, so tab new hanoi.ps. We have a program. I call that Hanoi. We begin, and we'll start there for now. We will need a procedure. We don't need to return anything, so we're just going to use a procedure. I'm going to call this step, and this will take targets. What do we need? Targets, temp. No, source, target, and temp. And these are going to be integers. Begin, end with a semicolon. We're going to call a step here. And actually, it does say we need to ask for a number. We're going to call this n. So this is going to be, does var go before or after procedures? We'll find out. It's fine. Var n is an integer. So we write how high? Sure. We read n as an integer, And then we go from step. We need a count. We might need a count here. Because if there's only one, yeah, I think we need a count there. We have source, 3, 2, and then n. So we have everything from 1. We want to move everything to 3, using our second peg as the temporary, and then we have n disks. And so the way we can do this is we can do if count is equal to 1, then we say write ln 1, 2, and then target. Else we recurse. No, it's not, that's not quite right. That's not quite right, because we need to move. Okay, we're gonna go back to this. All right, we restart here. We need to move the tower. So yeah, we need to move the tower from this to this. Okay, so we need to move the tower from that to that. We have from source to temp, using the target as the as our temp now, and then count -1. And then you write ln 1 to target. And then step from our temp to target using the source as our temporary, and then count -1 again. Now we can. This needs a begin. This needs an end. We can simplify this a little bit when we say count is 0. Then we can just do nothing. Which means if we say if count is greater than 0, then we do this. And then we just do nothing when count is less than 0. And so this can go down to 0. You do end up recursing one extra step, but it saves us from having to write this twice. This is not 1, this is source to target. Which, back then, would have probably been significant. You maybe would not have wanted to do that, but with modern systems, this is fine. Should be fine anyway. Okay. FPC Hanoi. Of course we have a syntax error. Expected semicolon the begin found at 4. Right, because you need to declare that. But other than that, sure, anyway. How high? Let's give it a 1 first. 1 to 3, okay. How high? 2. Let's test these instructions. I'm gonna put that over here. You should be able to see it if I move this like that. So, with 2 disks, I'm gonna pretend that this third one isn't here. So 1 to 2, 1 to 3, and then 2 to 3. So that works for that one. And then we say 3. And we have 1 to 3, 1 to 2, 3 to 2, 1 to 3, 2 to 1, 2 to 3, and then 1 to 3. That works. And then we'll have it to 4. So we have 1 to 2, 1 to 3, 2 to 3, 1 to 2, 3 to 1, 3 to 2, 1 to 2, 1 to 3, and so this is our main step there. That's this one here. And then I lost count. So this is the 1. I'm trying to find the 1 to 3, and then 2 to 3, 2 to 1, 3 to 1, 2 to 3, 1 to 2, 1 to 3, and then 2 to 3. And there we go. This works. It's very easy, but also it's easy because I know what the solution is. Hint, the problem, like all recursive problems, reduces itself, becoming simpler with each step. Remember the 3-disk problem. You first create a 2-disk tower on top of peg 2, which allows you to move the topmost disk on peg 1 to peg 3. Then you move the 2-disk tower on top of peg 3. It's the same with 4 disks. First create a 3-disk tower on peg 2, then move the biggest disk over to peg 3, and then move the 3-disk tower to peg 3. How do you create the 3-disk tower? Simple, we already know how to move a 3-disk tower from peg 1 to peg 3. This time you're just moving from peg 1 to peg 2. Then when the biggest peg is in place, you're moving the tower from peg 1 to peg 3. Basically whatever we did in the code. In this whole procedure, we can act as though the big disk doesn't exist, since it's guaranteed to be bigger than the others and thus poses no problem. Just utilize the 3-disk solution, switching the numbers around. Good luck. But yes, this. It's a fun problem to program. Let's see how they solve it. Towers of Hanoi. Var num disk integer. Procedure, do towers. So they have number disk, original peg, new peg, and temp peg. We have ours switched around. That's fine. Number disk on the original peg, peg number on the tower, peg number moved to tower 2, and temp peg, peg to use for temporary storage. Begin. Take care of the base case, 1 disk. Then you do this. They aren't even following the format. Hold up. They said using the... Okay. The algorithm is the important part here anyway, not the output. First, move all the disks except the bottom disk to temp peg, using new peg as a temporary peg for this transfer. So do towers num disk -1 reg temp and new, and then you move the bottom disk to the new one, and then you move the disk from the temp to the new. And that follows from here, from everything but the bottom one to the temp, from the source to the temp, then source to the target, and then the that stack from the temp to the target. So I have an if there, yeah. And then you have the main, write and then read ln. Read ln probably would have been smarter here, yes, but I guess it doesn't actually matter. Interesting. Actually, read ln. Why would you have to run it? It's fine. It's fine. I guess if you... Because if you do this... No, stop. Don't do that. If you do this, then you end up with this, which I guess... Sure. It's okay. The minimum number of moves is always 2 to the n minus 1, and the move where you're transferring the biggest disk is always the middle move of the entire sequence. Yes, indeed. Enumerated types. You can declare your own ordinal data types. You can do this in the type section of your program. Type data type identifier equals type specification. One way to do it is by creating an enumerated type. An enumerated type specification has the syntax this. Enums. That's what these are. Okay, these are enums. Enums in other languages. I thought these were tuples, but I guess if they have it, yeah, if they're types, then yeah, no, hold on. So they have tuples and they have enums. So these are, because they're types, these tuples are essentially enums. Or rather, they're using the tuple syntax. In any case, yes, they're enums. To make months starting from 1. So for example, if you wanted to declare the months of the year, you would do a type January, February, March, April, May, June, and so on. And these would be ordered from 0, 1, 2, 3 all the way to 11. And to make months starting from 1, you start here. You can assign more than one enumeration per value. Okay, so you can have values on them. January is 1, first month equals 1, February 2, second month is 2. I assume anything after that is auto-incremented from the last value. Or for the example below, results in January 1, February 2, May 5, June 6, and July 7. You can then declare a variable of that type. You can assign any enumerated variable to the variable. So month is assigned to January, or month is assigned to tmonth type 0. Okay, so you're indexing the enum directly. So this is this has to be an index then, and not the value. All the ordinal functions are valid on the enumerated type, or January is equal to 0 and or December equals 11. I feel like we never got introduced to this. Did we ever get introduced to ordinal functions? I feel like the answer is no. Oh, we did. I guess we did. For ordinal types, integer or character, where the allowable values have a distinct predecessor or successor, you can use these functions, chr, or the ordinal value, predecessor and successor. Okay. Yes, this makes sense. Or if the month variable should go next to calendaristic month, to call a call to such month can be made. Consider verifying with month is less than high tmonth type that there is a next month. We weren't introduced to this one. But I assume this is the highest one of the type. We weren't, right? Yeah, we weren't. Get number of elements in enumeration with ORD high tmonth type +1. Interesting that they don't have this built in. But I guess the number of times you would actually need to find the length of an enum is pretty rare. Because normally you're just getting the items, or you're just using the items of the enum, and not the length. Unless you want to iterate over those, but then you can just use an iterator. Oh, but then for in is a language extension, right? A few restrictions apply though. Enumerated types are internal to a program. They can neither be read from nor written to a text file. You must read data in and convert it to an enumerated type. Also, the identifier used in the type, such as January, cannot be used in another type. Okay, so these are typed, which means they can't mix. So it's not duck typed, it's all static type. One purpose of an enumerated type is to allow you, the programmer, to refer to meaningful names for data. In addition, enumerated types allow functions and procedures to be assured of a valid parameter, since only variables of the enumerated type can be passed in, and the value can only have one of the several enumerated values. Write and write-ln can be used to print a string representing the current value in an enumerated type variable. Write string. Do we learn this? I don't think we learn write string. But the destination is a string. Oh, that would be very useful. Yeah, that's very useful. Maybe we did learn this. Maybe we did learn this in the input-output. I don't need this one. Here's in the formatting output. Maybe they didn't. Yeah, write string would be useful. So yeah, that's basically an equivalent to C's F string F. C F printf F printf. No, S printf. Yeah, that's what it is. Something like that. Whereas more modern languages just have string interpolation. Where are we? The write string can be used to place a string representation of an enum value into a string, or in one shot get enum name. That's another function they haven't introduced. Also type info. T-month type ord month if type info unit is added in a uses clause. I haven't introduced these things yet. To walk over the enumerated definition, for I is assigned ord low month type to ord high month type. Okay, so good to know that you can to walk over it. Begin X get enum name type info T-month type ord I. I don't know. Oh wait, is this? Yeah, this. I think this gets the string representation. So for example, it gets January. Okay. Subranges. A subrange is defined in terms of another ordinal type. This type specification is lowest value to highest value, where lowest value is less than highest value and the two values are both in the range of another ordinal data type. For example, you may want to declare the days of the week as well as the work week. Days of the week is Sunday through Saturday, and then we say the days of work week is Monday through Friday using the range. You can also use subranges for built-in ordinal types such as char or integer. This is something I wish we had in JavaScript. Python has this. But yeah, good to know that Pascal has this too. I think I saw it in one of the earlier code examples that we saw. Suppose you wanted to read in 5,000 integers and do something with them. How would you store the integers? You can use 5,000 variables lapsing into AA, AB, AC, and so on. But this would grow tedious. After declaring those variables, you would have to read values into each of those variables. An array contains several storage spaces, all of the same type. You refer to each storage space with the array name and with a subscript. The type definition is type name equals array enumerated type of another data type. I swear we worked with arrays in an earlier chapter. The data type can be anything, even another array. Any enumerated type will do. You can specify the enumerated type inside brackets or use a predefined enumerated type. In other words, type enum type is 1 through 50. Oh, wait a minute. I guess this syntax only works with types, doesn't it? Okay. Array type, array enum type of integer. Wait, what? I'll keep reading. We'll see if that makes it any clearer. Aside, this is how strings are actually managed internally as arrays. Back before modern Pascal compilers added native support for strings, a programmer had to handle it themselves by declaring string packed array of 0 to 255 of character. Ah, okay. So this is these are your indices. I see. Okay. And using some kind of terminating character to signify the end of the string. Most of the time it's a null character, ordinal number 0 or ord 0. The pack specifier means that the array will be squeezed to take up the smallest amount of memory. So that means that if there's stuff at the end that isn't used, it will shrink it to whatever it actually just does use. Arrays of characters representing strings are often referred to as buffers, and errors in handling them in the C or C++ programming languages may lead to buffer overruns. A buffer overrun occurs when you try to put, say, a 200 character string into a 150 length array. If memory beyond the buffer is overwritten, and if that memory originally contained executable code, then the attacker has just managed to inject arbitrary code into your system. This is what caused this famous slammer worm that ran rampant on the internet for several days. Try it in Pascal and see what happens. I guess we can try that, sure. I actually don't know what the slammer worm was. It sounds familiar. Buffer overrun. Program overrun. Let's say this is just 10. var str is of type string. So I don't know if that's going to conflict with anything, so I'm just going to make this str t str. I don't know if it's going to conflict with a variable name. Begin, end, str is equal to, or is assigned to, how do you assign to this? I swear there was an array, hello? Wide strings only implemented as array of wide characters. I do not remember how to assign to an array, or how to initialize array. Pascal initialize array. I mean, maybe what's this here? Oh, right, because you can initialize in here. Whoops. Forgot about that. Okay. 0, 1, 2, 3. I don't want to have to write 10. Let's go with 5. So this now is 6, 0, 1, 2, 3, 4, 5, and make it 6. So we should get a compilation error here or something. FPC overrun, buffer overrun, syntax error. I'm gonna move this over here because I know this works. Okay, we're gonna do this the long way. So I guess this means that we only need to assign up to string 6 though, right? So if we do string 6, you want to make sure you have your semicolons. Range check error while evaluating constants 6 months between 0 and 5. Well, that's what I would expect. So I feel like this needs to give an example of what it would be. Arrays are useful if you want to store large quantities of data for later use in the program. They work especially well with for loops because the index can be used as the subscript. To read in 50 numbers, assume the following definitions. Array type is array 1 to 50 of integer, and var, my array type. For count is assign 1 to 50, do read my array count. Brackets enclose the superscripts, subscript when referring to arrays. Don't start your indices at 1. It feels less wrong to do that in Pascal though, for some reason. This isn't Lua, where indices start at 1, but for some reason it feels more acceptable to me. Just from reading all this stuff here, it feels more acceptable to start at 1. I think in part because you specify what your array indices are, but I think natively Pascal works with array indices starting at 0. Multi-dimensional arrays. You can have arrays in multiple dimensions. Okay, good. It has that built in, I guess. The comma separates the dimensions, and referring to the array would be done with A, 5, and 3. Two-dimensional arrays are useful for programming board games. The tic-tac-toe board could have the type and variable declarations. Is it perhaps the ranges are inclusive? Possibly. Yeah, because 1 to 50 would be 50 elements, whereas 0 to 50 would be 51. A tic-tac-toe board could have these types of variable declarations. Type status type is x, 0, or blank, so we're using an enum here. Board type is array 1 to 3, 1 to 3, two-dimensional array here of status type. So the elements are of status type, and then we have the var board is a board type. You could initialize the board with for count is 1, 2, 3. Do for count is 1, 2, 3. Do board count 1, count 2 is blank. You can of course use 3 or higher dimensional arrays. Good to know. Records. So these are kind of like objects in JavaScript. And key value pairs, basically. A record allows you to keep related data items in one structure. If you want information about a person, you may want to know name, age, city, state, and zip. To declare a record, you use type name equals record, identifier list 1, data type 1, identifier list, and data type n. I guess considering it's a type, it's more like an interface in TypeScript or an interface in Java. Because I think we have I was gonna say structs, but I think there are classes in Pascal. Class, struct. There was something in here. That's a constants. Okay, yeah, we have one-dimensional arrays with array constants here. This is how you create an array constant. Yeah, so we did see this. Yeah, okay. We did see the syntax before. And then we have records. Yeah, so we have worked with these. Set of month. We have sets. So to declare a record, you do this. For example, you do this. Each of the identifiers, name, age, city, state, and zip, are referred to as fields. You can access a field within a variable by variable identifier dot field identifier. The period separates the variable and the field name. There's a very useful statement for dealing with records. If you're going to be using one record variable for a long time and don't feel like typing the variable name over and over, you can strip off the variable name and use only field identifiers. You can do this by with record variable do begin end. So, interestingly enough, JavaScript does have this too. It's a very old statement and it's deprecated and you can't use it in strict mode, but it does have it. And the reason why it's more problematic to do it with JavaScript is because of the prototype chain and its prototype searching algorithm. There's no problem with that in Pascal because it doesn't have the prototype problem. Yeah, I guess this can be useful. I've been thinking about how to make a stream around the with statement in JavaScript because nobody knows about it, and it'd be kind of fun to play around with it. But I don't have anything that requires nested, like deeply nested objects. Actually, does Java have a with object or with statement? Because if Java doesn't have a with statement, why does JavaScript have it? Oh, it does? It doesn't. Okay. Interesting. Now, it may have pulled it from something like Pascal. I wouldn't be surprised. MoonScript does, and it may have gotten it from Ruby. So Ruby has it. I know JavaScript had... wait. JavaScript has had influence from... Why are they not using the logo? Actually, I'm going to put a pin on that, because... so, influenced by Java schemes, self, awk, and hypertalk. Scheme, I don't think it would have gotten it from. Java, definitely not, as we find out. Awk, I don't remember there being a with statement there. Self, I think, would be where it would have gotten its. Not that I know any self, but it process of elimination. Speaking of the logo, though, I found out recently that XML has a logo. This very much does not feel XML to me, because XML is very rigid and very strict, and this is very fluid. Very flowy. Visual Basic, I see. Yeah, this can be useful. Fields Y2K and XML belongs to the 70s. Pointers. So we do have pointers, and we did see pointers in the in one of the examples that we saw. A pointer is a data type which holds a memory address. A pointer can be thought of as a reference to that memory address, while a variable accesses that memory address directly. I feel like the word reference here is overloaded with the since we have actual references. If a variable is someone's phone number, then a pointer is the page and line number where it's listed in the phone book. To access the data stored in that memory address, you dereference the pointer. Yeah, pointers. So pointers you get from C and, or rather, are present in C, and people have trouble wrapping their heads around it as well. I never did, and yeah, to me they're very straightforward. And so I think where people struggle with this is the indirectness of pointers. And yeah, I think it's just because you have to think of in a layer of abstraction, but in a way, you know, programming is all abstraction. So I struggle to wonder where the roadblock there is. To declare a pointer data type, you must specify what it will point to. That data type is preceded with a caret. For example, if you are creating a pointer to an integer, you would use this code. So this is how we say is a pointer to an integer. So in C, this would be an asterisk. I've had a little success explaining pointers using switchx. Yeah, we had the benefit of that now because there is that one meme. That's a very good meme. Where did I see it? I think I saw it on our programmer memes. Is that the subreddit? Or something like that. Yeah, that one's a good one. I should really save that and put it somewhere. You can then, of course, declare variables to be of type pointer type. Before accessing a pointer, you block off an area in memory for that pointer to access. This is done with new pointer variable. Okay, so we actually do have to do a little bit of low-level memory management here. This is something you do have to do in C, and to a lesser extent C++. You still have to do this stuff in C++? I think you do. It's been a while. But definitely in C. To access the data at the pointer's memory location, you add a caret after the pointer name. Hold on, before accessing a pointer, you block off an area in memory for that pointer to access. This is only if you have to store things in the heap, right? Because if you have a pointer to another variable, surely you don't have to do this. To access the data at that pointer's memory location, you add a caret after the pointer name. For example, if pointer variable was declared as type pointer from above, you can assign the memory location a value by using pointer variable dereference is assigned to 5. Is assigned 5 rather. Okay. After you are done with the pointer, you must deallocate the memory space. Otherwise, each time the program is run, it will allocate more and more memory until your computer has no more. To deallocate the memory, use the dispose command. So, low-level memory management means that we have to allocate and do our own garbage collection. Won't do it for us, and that's how you get memory leaks. A pointer can be assigned to another pointer. However, note that since only the address, not the value, is being copied, once you modify the data located at one pointer, the other pointer, when dereferenced, also yields modified data. Also, if you free or deallocate a pointer, the copy pointer now points to meaningless data. Please tell me the compiler takes care of that and crashes the program if you try to access that. Trivial usage example, singly linked list. What is a pointer good for? Why can't you just use an integer in the examples above instead of using a pointer to an integer? Well, the above is clearly a contrived example. The real power of pointers is that, in conjunction with records, it makes dynamically sized data structures possible. If you need to store many items of one data type in order, you can use an array. However, your array has a predefined size. If you don't have a large enough size, you may not be able to accommodate all the data. If you have a huge array, you take up a lot of memory when sometimes that memory is not being used. A dynamic data structure, on the other hand, takes up only as much memory as is being used. What you do is to create a data type that points to a record. Then the record has that pointer type as one of its fields. For example, stacks and queues can all be implemented using this data structure. Pointer type is record type, or The type pointer type is a pointer to a record type. And record type is a record of data is an integer and next pointer type. Each element points to the next. The last record in the chain indicates that there is no next record by setting its next field to a value of nil. Fairly standard stuff if you've seen this in C before. Chapter 6, Final Words. Why do we not get an assignment? Okay. This concludes my informal course in Pascal. I should have a reasonable understanding of the basics of Pascal by now, though this tutorial is by no means comprehensive. Compiler manuals contain a wealth of information about additional syntactical elements and predefined routines for use in your programs. Here are free Pascal compiler manuals. I'm not going to look at those. The reference guide contains information about the system unit, which is used automatically with the program, while the unit's reference manual gives an idea of how many routines there are for accomplishing all sorts of tasks. Good luck in your future Pascal endeavors, and when you move on to other languages and find yourself using Pascal casing for variable names, remember how Pascal has left an indelible mark on computer programming, even though other languages have risen to prominence. It definitely has its place in history. And I realized I've been doing all this without doing Pascal casing, because Pascal's convention is to use uppercase for your variables. Oh well, that's fine. But that brings us to the end of the tutorial. I kind of wish they had an exercise for this one, but oh well. It's not like we didn't use them before. But I suppose these will come in handy perhaps later on. We're not doing the programming for the pressure calculator today. That's going to be a future stream. I do want to try making a GUI for it because I think it was Lazarus. Lazarus ID has capabilities for creating a GUI, because creating a pressure calculator just with code with standard input and output, that's not going to be a long stream. So I think it makes sense to make a GUI, but I also have to figure out how to do that. And that I might try to learn that off stream because it is a little bit involved. But it's somewhere in this wiki somewhere. For any of you in the Discord, I'll probably, if I do end up learning that at some point, which I should, I will be posting links in the programming channel in the Discord. So if that's something you're interested in looking up, you can go ahead and join there. But yeah, so now we know the basics of Pascal. I don't know when it is we're going to be creating the thing, but it will be at some point. And so for those of you who weren't here the first time, this is all to create a pressure calculator because it's a bad pun. Pascal being the unit of pressure, both of which named after Blaise Pascal. But yeah, this, even if I don't successfully make the calculator, this has been an interesting delve into into a historical programming language, which, as I said earlier, is surprisingly still used by a number of people. I think it's fallen off the top 10 in this year, but last year was at 9th place. Would I want to program in Pascal for things? Probably not. It does feel a little bit odd in the way it has certain decisions, but it suited the programming community for the time that it did, so I can't fault it too much. But yeah, no, Pascal is still being maintained, I think, so it's definitely worth knowing about, if not actually using it. So this was good. But yeah, if you want to try this out yourself, the tutorial is pinned in both chats there. And for anyone watching the VODs on YouTube, the tutorial is in the description, as well as the first part of this tutorial series, the first VOD. Okay, for those of you on Twitch, we're going to find something to raise to stick around. But in the meantime, next stream, and hopefully I put this up right, tomorrow we are going to be playing Tenho Mahjong, because Tenho accounts expire after 180 days and it's been almost 160. So I gotta get this in if I don't want my account to expire. So that's gonna be tomorrow, and then Friday we're gonna be doing some more music arrangements of Mountain. Yeah, that's it. For anyone who's new here, my name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux. For once, we actually did do programming. Don't get to do that very often. But yeah. Words. I think that's it. Alright, yeah, like I said, on Twitch, we're going to find something to raid, so stick around. And on YouTube, we will just end as usual. So until next time, good night. Something's out of order here. Something's not right. But yeah, good night. We'll see you next stream. Bye. Twitch, it seems like you're gonna go into ads, so I'm gonna let the ad break run and then we'll raid afterwards. So sit tight. Twitch, where's your ad? Come on. There it is. Okay. Well, in the meantime, I guess I can chat to YouTube chat, so glad and congrats on finishing your letter. Always good to be productive and finish stuff. And yeah, I don't know. I feel like there's stuff that I haven't streamed in a week. This feels a little bit. I feel a little bit out of practice, but at the same time, maybe not. I don't know. It's only been a week. Alright, I got 40 seconds left to stall, and then we can welcome Twitch back. Yeah, I'm looking forward to stuff next week. There's stuff coming up. I might consider. Actually, no, I'm not gonna say anything just in case plans change, but there things, yeah, next week seems like it's gonna be good. But it's about as much as I'll say. Hopefully things go to plan. 5 seconds. Alright, welcome back Twitch. I have found something to raid. We're going to go visit Nat Baka. They are fixing some code in Ren'Py. I don't ever know how to pronounce that. But software development is apt for what we're doing. This is the raid message if you'd like to participate. You can go ahead and copy that and paste it when we get over there. I've never encountered this streamer, so we'll find out together. Okay, yeah, well that is that, and we'll see you next time, and good night, bye. Oh yeah, that's what I forgot. Thanks for coming. We gotta thank your viewers. But yes, thanks for coming, and we'll see you next time. Bye.